All right, let's talk about the very core of any Linux system, user and group management. Now, this isn't just about making new accounts. Nope. This is about understanding the actual blueprint for a secure, organized system where lots of people can work without getting in each other's way. Let's dive into how Linux keeps it all straight.
Okay, so let's just jump right into a real-world problem. Picture this, you're in charge of a server and it has 100 different users. How on earth do you make sure everyone has the access they need, but only the access they need? How do you stop them from tripping over each other, or even worse, peeking at sensitive files? This is the exact problem that a good user management system is built to solve.
So the solution actually starts with two really simple ideas: users and groups. A user is just a unique identity, a login, and a group is, well, it's just a collection of those users. This simple structure is the foundation of something called discretionary access control, or DAC. It's basically the rulebook that Linux follows to decide who gets to touch what.
Now, here's where it gets interesting. Every single user belongs to one primary group. That's kind of their default home base. But they can also be a member of a bunch of secondary groups. You can think of it like this. Your primary group is your main department, but the secondary groups are all the special project teams you're on. Each one gives you different permissions.
So how does Linux keep track of all this stuff? It's not magic. It all boils down to a few really important text files. Let's pop the hood and take a look at the files that act as the system's official record book for every user and every group.
First up, we have etc password. This is the main user database. Each line is one user, and you can see it's broken up by colons into 7 fields. You've got the username, a unique user ID or UID, their home directory, and their default shell. Quick tip, UIDs under 1,000 are usually for system stuff, not actual people. But check out that second field, the password. See that little X? That is super important. It means the real password is not stored here anymore. That would be a massive security flaw. Instead, that X tells us to go look in a much safer place.
And that safer place is /etc/shadow. This file is like Fort Knox. Only the root user can even read it. This is where the real password lives, but it's encrypted or hashed, so it's just a long string of gibberish. This file also tracks all the password rules, like when it needs to be changed and when the account might expire. This separation of files is a huge part of what makes Linux secure.
And to round out our key files, we have /etc_group, which, no surprise, defines the groups and who's in them. And then you have this cool little directory called /etc/skel. Think of it as a skeleton or a template. You can put files in here like a pre-configured settings file, and they'll automatically be copied to every new user's home directory the moment you create their account. Pretty handy, right?
Okay, so we've seen the blueprint. Now let's look at the tools we use to actually build something. A user's life on a system is pretty simple. They're created, their account gets modified over time, and eventually it gets deleted. And guess what? There's a specific command for each step of that journey.
To bring a new user into the world, we use the user add command. This is our go-to tool for adding an account. By itself, it's pretty basic, but its real power is how it interacts with all those system files we just learned about.
So what's really going on when you type user add? It's not just one thing. That simple command kicks off a whole chain reaction. It writes new lines in etc password and etc shadow. It can create a brand new home directory, and then it populates that directory by copying everything from etc skel. See, these commands are really just safe, smart ways to edit those core files without messing anything up.
But hold on, there's a critical catch. After you run user add, the account is there, but it's locked. Nobody can log in with it yet. The final, absolutely essential step is to use the passwd command to give that user a password. That's what flips the switch and makes the account active.
As time goes on, things change, right? A user might need access to a new tool, or you might need to temporarily lock their account. For any and all of these changes, we have usermod. This is the Swiss Army knife of user management.
Seriously, you can do almost anything with usermod. You can change their default command shell with the -s flag, you can change their login name with -l, you can lock an account with -l and unlock it with -u. You can even pick up and move their entire home directory to a new spot. It's just an incredibly powerful tool to have.
And finally, when a user leaves the team, we use userdel to complete the cycle. But, and this is a big but, pay attention to the R flag. If you just type userdel, it removes the user's name from the system files, but it leaves all their stuff behind in their home directory. If you add R, you're telling the system, get rid of the user and all of their files. It's a clean sweep.
Okay, let's switch gears and talk about groups. If user accounts are all about individuals, groups are all about teamwork. They are the absolute best way to give a whole team of people shared access to the same files and projects without having to manage permissions for each person one by one.
And the commands for groups are super intuitive because they look just like the user commands. You use group add to make a new one, group mod to change it, and group del to get rid of it. It's a really straightforward toolkit for keeping your users organized.
Now I need you to lean in and listen to this, because this is probably the single most common and dangerous mistake sysadmins make. When you use usermod to add someone to a group, if you just use the -G flag, you will completely wipe out all the other groups they belong to. The only right way to do it is to use -AG. The A stands for append, and it tells the system to add the user to the new group without kicking them out of their old ones. Please, please remember that.
Look, knowing the commands is one thing, but using them wisely, that's what separates the beginners from the pros. So let's cover a few best practices that will really level up your management skills.
Remember all that password expiration info tucked away in the /etc shadow file? You don't want to try and read that thing by hand. The tool for the job is change, which is short for change age. If you run change-l with a username, you get a nice, clean report of that user's password rules. It's the professional way to enforce security policy.
And let's finish with some quick rules of the road. Rule 1, never, ever, ever edit files like etc password by hand. The tools exist for a reason, use them. We just talked about the -AG nightmare, so don't fall into that trap. Also, avoid things like shared group passwords. That's just bad practice. And finally, always remember that userdel-r is forever. Make sure you have backups before you delete someone's work permanently.
So, let's do a quick recap of our toolbox. For the user lifecycle, we've got user add, user mod, and user del. To handle passwords, we use passw. And for organizing everyone and setting policy, we use group add and change. That's it. That's the core toolkit that gives you total control over the users on your system.
And that really brings us to the big idea here. Mastering these tools isn't just about system administration, it's about being an architect. You are literally designing the rules, the structure, and the security for a digital community. You're not just managing a list of accounts, you're building a space where people can work together securely and get things done. So the only question is, what kind of community are you going to build?